Okay, this evening's video is actually more to test the video camera. I've altered the format of the video from, I was uploading MP4s to YouTube, and I've altered that now to movie files, MOV files, which is the QuickTime Apple format. I've also made a few adjustments to the exposure on the camera, so I'm actually overexposing the image very slightly to hopefully give a better exposure on sort of darker images. I also hope it improves the sound quality slightly. It did actually sound like the frequency response of the sound was actually better, but the MP4 it seems to have a sort of like a roll off after about 5 kilohertz, and it sounds like the frequency response is slightly better extended with this MOV format. So for the purpose of this video, I'm going to have a quick look at this EMC comparator bridge that I bought a year and a half, 2 years ago. I've changed a few bits and pieces in it. The wiring isn't particularly nice in there, and I'm trying to find a service manual to so if I can rewire it and recap it. I could probably just rewire it and recap it from scratch actually, but I just prefer to have a schematic with me so I can see what exactly I'm doing. It uses an EZ80, no, it's an EZ81 I think it is, rectifier valve, which I broke when I first took the thing apart, and I'm actually running it with a semiconductor 1N4007 silicon diode instead. It's designed to work on 115 volts only. It's actually working on 240. I'm running off an auto transformer, and I think the auto transformer isn't giving quite enough volts to make the thing work properly. It's got a voltage output here for electrolytic testing and a couple of other caps testing. You know, like you can check paper and mica caps. And at 500 volts it can only manage about 440, 450. But apart from that, it does work okay, and it's quite a nice little bridge actually. I've replaced the pot in it. Luckily, it has some pots, and this is a precision sort of linear pot, and it was very noisy, and I've tried cleaning it up, and it didn't help a lot. But I put a new pot in there, and it's actually really nicely smooth now, so that seems to work okay. It's got this in-circuit tester that you're supposed to be able to check capacitors and resistors in circuit. It tends not to work very well anyway, but that's all part of this open and close testing here. Not really bothered about that, but what I am interested in is the capacitance bridge, and this is an old electrolytic I've got out of an old radio, and it's a 50 microfarad. And from memory, when I did test it, it was actually okay. That's why I've kept it. But the idea of this, I'll just turn this light off here, and you can see the magic eye here, or the eye as they call it. You adjust this dial here for maximum eye opening. I think what I'll do is I'll turn the backlight off. This will also test the noise on the camera. So you turn the dial here for maximum eye opening. Okay, and it's off the end of the scale, so you move to the next scale. Just check you're not shorting anything out. Okay, it's peaking around there, you see. So the maximum eye opening is around there, and you can, I don't know if you can see that in this light, but that is actually 50 microfarads, which is actually what this capacitor is. And we'll move it to the other section of the capacitor. Oh, that's the other thing you have to be a bit careful. They do generate quite a lot of voltage, these bridges, so just bear that in mind when you're working with it. It can put 500 volts DC onto these leads, and that across a capacitor is quite dangerous. So, well, it's very dangerous. So, despite what you might have read or heard in other videos on YouTube, that will kill you if you're unlucky. So let's try it on the other one. That's on the other part of the cap, and you can see the same. It's opening about there, but it's higher off the range. So let's move up the range. And there you see it's around, according to this, it says it's around 160 microfarads. Well, it's actually supposed to be 100 microfarads. And the power factor is basically the test for losses in the capacitor, and it gives you a better idea of how good the capacitor is. But you see the power factor doesn't drop back that much, so that looks okay. The other test it will do is it will do voltage test it, so you can test the capacitor at its rated voltage, and this is where you have to be a bit careful. This cap's rated at, on the yellow, 275 volts, so you can apply a voltage up to 275 volts and just wait for an eye. The eye should open at 275 volts. If it doesn't open, it does mean the capacitor's leaky and shouldn't be used at its rated voltage. It's going to take a while for the eye to open because it's obviously charging quite a large value capacitor, but you can see slowly the eye is starting to open. So just wait for a minute. And you see I've probably got the voltage at 300 volts. As I was saying, that you can't get the full voltage out of the rig, and this is probably around 275 volts or so. Let's just check the voltage. Checking with the fluke, see what we've got. Okay, that's at 230, and it's obviously still charging the cap up. Yeah, 230 volts and climbing. So the eye is starting to open. It does suggest that this capacitor is probably a little bit leaky, but it is a 40-year-old capacitor, so I'm not that bothered about that, to be honest with you. But a useful test, if I reduce it to 250 volts, you see the eye opens initially and then it closes. So certainly at probably around 200 volts, this capacitor is absolutely fine. Now you must be careful that when you finish with this test, you turn it to minimum, just to make sure that the capacitor is discharged, and always check with the multimeter. There you go, you see it's dropped down, that it's okay, and just short it out to be absolutely sure. So the capacitance bridge is actually quite a nice feature on this. Let's try this, put the lights back on. Let's try this little ceramic here. Now likewise you can do, let's probably go paper mica test, probably nearest to ceramic as you can, rated at 50 volts this capacitor. You can see the cap, I don't know if you can see that, but the eye opens and closes and opens straight away to show that there's no leakage at all with that capacitor. You can check it for capacitance the same way as we did before, looking for eye opening, just there you go, and run the 0.1 to 50 microfarad range. So this is a 0.1 capacitor according to this, and it's a 104, so yep, that's a 0.1. So these are nice, these sets, and they're quite useful for testing the performance of a capacitor. And there's something about the eye gives you a better idea of what the capacitor is doing. I mean, the weighing curve's great, and that's what I use most of the time. Or even something like the Tinsley Prism Raycord knockoff is also very good. But these are quite a nice old valve tester, and they're quite easy to find, especially in the States. If you live in the States, they're easy to find. Buy one on eBay, and but just be careful. Remember that there are, certainly on the high voltage tests with the electrolytics, there is a lot of DC voltage there. You're probably fairly safe because it's probably fairly well current limited. But if you've got a big capacitor on the end, it can be very nasty. Anyway, thanks for watching, and